Hello guys, my name is Rutvik and welcome to my YouTube channel. In this video, we are going to talk about equation of line, hyperplane and plane. So first of all, why we need to learn this, right? So suppose you are working in a XYZ company as a data scientist and they have a business problem, and this business problem is belong to a classification task. As you probably know that in the machine learning or data science, whenever you are working with supervised machine learning, at that time you are working with only two type of problem. First one is the classification, second one is the regression. So whenever you are working with classification problem, at that time you need to differentiate that particular data point belong from which class. So suppose here we have a class, here we have a two class classification problem, right? And here you have a data called A, and here we have a two class, and two of them, for one of them is positive and second one is a negative, right? So you need to identify that this particular data point belong to which class, either positive or negative, right? After understanding the business problem, you collect the data, and now it's the time to pre-process the data. So if you have only two-dimensional data, suppose you have only two columns in the data set, so to separate this data set, suppose like this, here you have all the data, and here you generate a line, and you write an algorithm for this to separate the data. Whatever data, right, whatever data occur, whatever data is placed before upper part of this line, those all data are positive as per your algorithm, and whatever data is below this line, it is a negative. Whatever data points are below this line, it is a those all data are negative. So as per you design this algorithm, and but you need to create a line. Same thing you done for whenever you have a three-dimensional data like three columns. At that time you are trying to separate three type of data using a hyperplane. So suppose you have a chart like this. Here we have all the data, as you can see, and here I'm not good at drawing, so this. So whatever data is upper from this, you are either differentiate in a positive, negative, and none. Okay. So to generate this hyperplane, to generate this line, we need to learn equation. So that's why in this video we are going to discuss about the equation. Okay. Okay. So now first topics, how we can differentiate the equation of line. In 10th or maybe 12th class, you learn about the equation of line, right? So what is the equation of line? Equation of line is represent like this: a plus by plus c is equal to 0, right? So whenever you have two-dimensional data, or you have two-dimensional data which where one dimension represent the x and one dimension is represented by the y, right? Where a and b, a and b are coefficient, or in the machine learning term or data science term, you can represent A and B as weights. Whenever you are using C as a bias, okay. So suppose when you are working with, so basically you got this equation from slope equation, right? You probably heard the equation of slope. So equation is of slope is like this: y is equal to mx plus c, right? Where c is equal to bias, right? Where m represents slope, or x represent the one dimension and the second y is represent to another dimension. Okay. After learning the equation, after seeing the equation of xa plus yb plus c is equal to 0, we are going to try generate the equation of hyperplane, sorry, equation of plane, right? So suppose ax is represent a one dimensional data, by is represent a two dimensional data, so here we have equation for two dimensions. And if we write cz, where z is a variable and c is a particular constant number, right? And if I write a constant number without any variable, okay, then this equation is belong to a plane. So suppose if we have a four-dimensional data, then we need to write four-dimensional. Sorry, we need to write a variable along with a weights. Suppose if we have a four-dimensional data and we want to generate an equation for that. So suppose ax plus by plus cz plus nw is equal to nw plus d is equal to 0, like this. So how can we write in a general form for n dimensional? How can we write a equation of general form of equation for n dimensional data? So suppose instead of writing, wait, because here a, b, c, n are the equation. Sorry, n, a, b, c, or n are the coefficient, right? To represent a coefficient, we can write like this: w1 x1 w2 x2 plus w3 x3 plus, here we have a bias, is equal to 0. So x1 x2 x3, here we using as a variable, using it as a variable which represent the dimensions, right? Okay. So suppose we have a vector in which we have a value w1, w2, w3, w4 up to wn. So this is a vector, this is a row vector, right? Okay. And suppose, just hold on for a second. I'm going to write again. Suppose we are trying to get this equation 2x2 plus w3 x3 plus bias. Okay, so we can see that we are going to plot a vector instead of writing, where we store all the weights for 2, and I'm trying to generate a generalized form of equation. So with the help of this equation, we can plot any, we can write any equation for any dimension, right? So in this we have values, in this matrix we have a value like w1 w3 w3 w2 w3 w4 up to wn. So basically it's a row vector When in another row vector we have values like x1 which contain all the variables which represent the dimensions x3, x4 up to xn, right? Okay. Now I want to come up with where we have a bias. We have another row vector is called as a bias. Okay. So okay. Instead of writing this bias as a row vector, I'm going to write this as a column vector. Right. B1, B2, B3, B4 up to Bn. Okay. So now I want to perform some operation on three vectors and I want to get this equation. So suppose if we write w into x, but this multiplication won't be performed. Why? Because as you can see here, we have a different orbit, right? We have a same orbit, and that won't be perform multiplication between two vectors. To perform multiplication, we need to change the orbit of x, or either we need to change the orbit of w. So we are going to change the orbit of w, and with the help of transpose. So when we use a transpose, the how whatever column is become a whatever column here, it become a row, and whatever row it become a column, right? So when we perform a transpose on a row vector, that row vector become a column vector. So as you can see here, if we perform a transpose on a w, then here we get n cross 1 orbit, and now we can perform multiplication on the data, and now here we can write like this. Okay, so here we get the equation for this, and if we generalize this term, then the term is like this: w1 x1 plus b1 for w2 x2, like this. Okay, I forgot about this, plus b is equal to 0. So this is the generalization form of equation. So with the help of this equation you can calculate, right? With the help of this equation you can calculate any, you can calculate line, plane and hyperplane. So thank you for watching.